बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम डियर स्टूडेंट्स। आज का हमारा जो टॉपिक है दैट इज़ फोटो इलेक्ट्रिक इफेक्ट। फोटो मीन्स लाइट, इलेक्ट्रिक मीन करंट or electricity, and effect mean process. So it means by means of light we can produce current. So here it is defined as the process in which we incident a light of suitable frequency on the metal surface it will eject electrons from the metal. So these electrons are called photoelectrons, and this effect is called photoelectric effect. Okay, suppose we have an atom which consists of electron. Okay, if we incident electron on this electron and this electron is get ejected, so this is called electrical ejection. This is called electrical emission or electrical ejection. Okay, suppose if we have an electron and if we heat them and this electrons get ejected, so this is called thermionic emission or heat emission. Okay, and if we have an electron and if we incident a light on this electron and this electron is get ejected, this is called optical emission or this is called photoelectric emission. Okay, now suppose we have a metal surface. We know that metal consists of large number of free electrons. So in metal we have a large number of free electrons, and whenever we incident a light on this electron, so this electron will be get ejected, will produce current. So this is called photoelectric effect. So remember, this light should be ultraviolet. Okay, this light should be ultraviolet. The energy of this light should be less than 0.5 mega electron volt. So this light should be ultraviolet light. Okay, now this experiment was presented by Heinrich Hertz. He performed this experiment in a discharge tube. We have a discharge tube. Over here there are two electrodes and the emitter is connected. Emitter will detect the current. Okay, now there is a quartz window. Quartz window means which is transparent to the ultraviolet light. So the light will come from sunlight will come, that is ultraviolet light. Sunlight is ultraviolet light. So ultraviolet light comes and hit the metal surface, and here there are large number of electrons. So electrons will gain energy, so they will come out from the metal surface. So the energy by which it can eject from the metal, it can come out from the metal, that is called work function. So work function is an energy. Work function is an energy. Which energy? The energy utilizes by which electron can come out from the metal surface, that is called work function. Okay, now the remaining energy will be used as a kinetic energy. Okay, so work function is defined as the minimum energy required to eject the electron from the metal is called work function. The minimum energy required to eject the electron from the metal is called work function. Okay. One is the ionization energy. Remember, ionization energy is also the minimum energy required to eject the electron, but from the gaseous atom. When the atom is isolated and you provide the energy and you eject the electron, that energy is called ionization energy. And work function when the atoms are present in a compact form. When the atoms are present in a compact form and you give energy to those atoms and the electron is get ejected from those atoms, that energy is called the work function. Okay. Now here, the energy comes, the ultraviolet light come and fall on the metal and it ejected the electron, so that energy is called the work function, represented by phi. This work function is represented by phi. So this electron will be comes out by some extent of energy, and the remaining energy will be used as a kinetic energy. So this electron will be moved and will deposit on this electrode, so emitter will note the current. So we produce light, we incident light, and this producing electrical energy. So this process is called the photoelectric effect. Einstein explained this process by this equation, and he got it the Nobel Prize by this equation. He said that the incident energy is utilized in two forms, the work function and the kinetic energy. Suppose we incident an energy of 100 joule, and this energy, this 100 joule comes and fall on the metal. Suppose by 20 joule energy the electrons comes out, so it means 20 joule energy is utilized by the ejection of electron, and the remaining energy 80 joule will be used as a kinetic energy. So it means that the electron will be get ejected by 20 joule energy, so that is called the work function. Okay. Now the remaining energy, that is 80 joule, will be used as the kinetic energy. This equation was presented by Einstein. Okay. Remember, the work function is constant for a material. Means the work function depending upon the nature of the material. Means work function depend upon the Z. Z means the atomic number. If the atomic number of the material is high, the work function will be very greater. So work function depends upon the nature of the material. If the nature of the material is changed, so it means work function will be changed. Okay. So why we are using metal? Because the work function of the metals are very small. Means we can eject the electron by small energy from the metals. Okay. Another thing is threshold frequency. Threshold frequency represented by F naught. So it is defined as the minimum energy the minimum frequency by which electron can be ejected is called F naught, threshold frequency. Okay. So work function is the minimum energy and threshold frequency is the minimum frequency. So it means according to Planck's, energy and frequency both are directly proportional. According to Planck's, energy and frequency are directly proportional. So energy will be equal to hf naught. Okay. Now here work function is equal to hf naught. Now Einstein equation said that incident energy will be utilized in two forms, work function plus kinetic energy. Okay. Now suppose we incident 100 joule energy, 20 joule utilizes in the ejection of electron and 80 joule is utilizes in the form of kinetic energy. Okay. If we double the energy, incident energy, the work function will remain same because the material is same. Now the kinetic energy will be get increases. So it means that the kinetic energy is depending upon the incident energy. Okay, remember, incident energy is equal to HF. So it means the kinetic energy is also depending upon the incident frequency, and the kinetic energy is also depending upon the incident wavelength. Suppose if the incident wavelength is get decreased, the incident energy will be get increased. If the incident energy increased, kinetic energy will be increased. Okay. If the wavelength is increasing, if we increase the wavelength, the incident energy will be decreased. If the incident energy decrease, kinetic energy will be smaller. So it means the kinetic energy depending upon the incident energy, incident frequency, and incident wavelength. Okay. But remember, kinetic energy is also depending upon the work function. Means kinetic energy is also depending upon the nature of the material. If you uh, change the nature of the material, the kinetic energy will be different. Suppose if we have a material which has a work function of 20 joule, suppose we incident 100 joule energy and 20 joule is used in work function and 80 joule is used in kinetic energy. If you use such a material which has a work function very smaller, so we incident 100 joule of energy and the work function is 5 joule, so the remaining energy will be 95 joule. So it means the kinetic energy will be get increases because the work function is smaller. So it means that kinetic energy is also depending on the nature of the material, means the work function. If the work function is smaller, kinetic energy will be smaller. Okay. Another thing is stopping potential. Another thing is stopping potential. Look at the name. Stopping potential means the voltage will stop. The potential means voltage. The voltage will stop. So the potential by which the kinetic energy of electron becomes zero is called V naught. V naught means the stopping potential. So the potential by which the kinetic energy of the electron becomes zero, that is called stopping potential. Okay. Now look, remember the stopping potential depending upon the kinetic energy. If the kinetic energy is greater, stopping potential will be greater. If the kinetic energy is smaller, stopping potential will be smaller. Suppose if we have a discharge tube and there is a metal surface, there is an electrode, we connect this electrode to the negative terminal and this electrode to the positive terminal, and we connect a voltmeter in parallel to the battery. Okay. Now look at here. This metal surface connect to the negative terminal, so this is cathode, and this connect to the positive terminal, so this is anode. Okay. The light comes, ultraviolet light comes and incident on the metal surface. When it incident on the metal surface, so it will eject the electron. If it eject the electron, that energy is called work function. The remaining energy will be used as a kinetic energy. So this electron is moving towards right, towards the anode. Okay. This electron is moving towards the anode. Okay. Now remember, if we reverse the terminal, by a converter, so look at here what will happen. So suppose we reverse the terminal as we connect the negative terminal with this electrode, so it becomes cathode, and positive terminal with this electrode, so it becomes anode. Okay. Now what will happen? We know that the electron has negative charge. We know that the electron is negatively charged. When the electron is moving towards right, and moving, the speed of the electron will be get decreased. Decrease means the electron will be decelerated and the speed will be decreasing and stop. Why the electron will be stopped here? Because as the electron is moving, the repulsion between the electron and the electrode will be increases. So due to the high repulsion, the electron will be get stopped. So we will note that voltage by voltmeter. So that voltage is called the stopping potential. So what determines the stopping potential? Stopping potential determines the kinetic energy. So stopping potential will determine the kinetic energy of electron. If the kinetic energy is smaller, we can stop the electron by smaller potential. If the kinetic energy is larger, we can stop the electron by larger energy. So stopping potential calculate the kinetic energy of electron. Okay. Another thing is intensity of light. Intensity of light. Intensity means the energy transmitted per unit area per unit time. Okay, this is the definition of intensity of light. Okay. Now, according to Planck's, energy is defined as NHF. Okay. So the definition of intensity will be number of photons per unit area per unit time. So the definition of intensity is number of photons per unit area per unit time. So for the simplicity, we can call the intensity as the number of photons. Number of photons. Okay. For the simplicity purpose, we say that this intensity is defined as number of photons. So it means that if we increase the number of photons, it means we increase the intensity. In our daily life, intensity means the brightness. If we increase the intensity, it means that we increases the brightness. Okay. This is one of the most important relation which shows the particle nature of light in photoelectric effect, that is intensity is directly proportional to current. It means that whenever intensity means number of photons, current means number of electrons. Okay. Whenever we increased the number of photons, the number of electrons will increased, means the intensity is directly proportional to photocurrent. So the magnitude of current is depending upon the intensity of light. If you increase the intensity of light, the magnitude of current will increase. Okay. If you suppose, I'm giving you a rough example. If you incident 5 electrons on a metal surface, if you incident 5 photons on a metal surface, suppose it will eject 5 electrons. If you incident 100 photons on a metal surface, so it will eject 100 electrons. So it means that if you increase the number of photons, the number of ejected electron will be increases. So the photocurrent strength or the photo magnitude of photocurrent depends upon the intensity. Okay. Now, classical physics say that photoelectric effect is a function of intensity, not on threshold. Okay. The photoelectric effect is a function of intensity. Photoelectric PEE means photoelectric effect is a function of intensity, not on threshold. F not mean threshold. Okay. It means the ejection of electron is not depending upon the threshold. The ejection is only depending upon the intensity. Suppose if we have a metal surface, we have an electron, we incident a single photon which has a frequency less than the threshold. Suppose this photon has frequency less than threshold, and we incident this single photon on the electron will be get ejected. So if not ejected, so introduce 2 photons on the metal surface, so the electron will be get ejected. If not ejected, then introduce 4 photons, incident 4 photons, the electron will be get ejected. If not ejected, then incident 100 photons on the electron, so electron will be get ejected. So if not ejected, so increase the number of photons, so a stage may come that electron will be get ejected. So this theory gives by the classical theory, and classical theory say that the ejection is a time delay process. The ejection is a time delay process, means ejection will take times. the photon will comes incident and electron, the photon will comes incident, and another photon will come incident electron, the electron will be get heated, the electron will be get warmed, after some time the electron will be get ejected. This theory was presented by the classical physics. Okay, now the modern physics comes and say that no, it is wrong. It is wrong. They say that threshold frequency is a function of photoelectric effect, means the ejection is depending upon the threshold frequency. So suppose if we have a electron and if we have one photon means the minimum intensity. One photon means the minimum intensity, and its frequency is greater than the threshold or equal to threshold. The frequency of this single photon is equal to threshold or greater than threshold. So this single photon will come and it will eject the electron. So experimentally that is correct. So it means that if we have a minimum intensity but the frequency should be greater than the threshold or equal to threshold, so the electron will get ejected. So this is true. So it means that and another thing, modern physics say that ejection is not a time delay process. Ejection is instantaneous process. Ejection is instantaneous process, means whenever you incident a photon, electron will be ejected at the same time. Electron will be ejected. So it means that it is not the time delay process. So classical physics was completely failed to explain the photoelectric effect, and modern physics was successfully explained the photoelectric effect. That is why it is proved by this experiment that light has a particle nature. Okay. If you have any queries, any questions about this topic, so you can comments on this video, or you can text, you can WhatsApp in your WhatsApp group. I'll inshallah explain it. Okay, thank you. Take care. Allah Hafiz.